I was still waiting for more people to join, but I see it's already 25 too. So we can get started. Thank you everyone for joining. For those who were here last week, thank you for coming back. My name is Tondani Moketi. I'm your facilitator for the first year information systems academic literacies sessions. So we'll be working together for the rest of the year. So today we are talking about computers and their business applications. This is for your module INF1505. Like I explained last week, in these sessions, we do not cover the module content in detail. We give you the essential skills that are important for you to be able to pass your module. So these sessions are not a replacement for you going to and studying your textbook. So it is just supplementary to the tools that you already have. And I think the lecturer also has got sessions. Please attend those sessions because they are beneficial for you to understand the content of the module. So there is a lot of theory to cover for this topic, but as a guide, I did say last time that you must use your tutorial 101 as your guiding map. So you need to look at the lesson outcomes from there. Okay. So for those who are new, just a bit of rules of engagement. So when you are in these sessions, we ask that you please switch off your videos, mute your microphone so that you don't disturb others with the noise. Raise your virtual hand to ask a question. And please complete the attendance register. I've pasted the link here on the chat. Please complete the attendance register. And at the end, I will ask you to complete the evaluation form. It is just for us to gather information. But most importantly, I would like for you guys to please participate and feel free to ask questions, make comments in the chat, or raise your hand if you want to speak. You can use the reaction emojis. Feel free to make this interactive. And if you have any technical queries, please you just send an email to the City and Touch email address, then they will assist you. You just need to make sure that you provide your student number so that they can be able to assist you. So today we're talking about computers and their business applications. But before we get there, I just want to talk about some outcomes for today's lesson. As is for us to be able to define a computer system and describe its components, and to be able to explain the factors that distinguish our computing power in computers. And we'll also discuss the types of input, output, and memory devices. And then there is quite a lot of detail that you can go and read for yourself in the textbook. So just a little bit of recap from last week, because remember, all the content for this module, they are related to each other. So you need to understand the basics of what a management information system is. So that is why last week we started with the management information topic, because it is the foundation that you must understand in order to make sense of the content that is coming later. So last week's topic was a high level. We defined what a management information system is, and that it is a computer-based system that collects, organizes, stores, and analyzes data. But also more importantly, the function of management information systems is that it supports managerial decision making in any organization because of the data that is collected in the MIS. So last week, we also talked about the importance of computers and IT infrastructure, that this is the backbone of any management information system. We also said that an MIS combines different areas or departments, if you can call it departments, in an organization. So we discussed an example from retail space, and we said that the MIS in a retail space can have a portion in the same system that covers the sales, another system that covers distribution, another module for stock and inventory and finance, management reporting, and so forth. That is why we said that most of the management information systems are divided into modules depending on what the department is using the software for. But in the end, because it is one management information system, all of these things are linked in the database. So those are some of the things that we discussed last week. Thank you for the thumbs up. So I hope that helps with a bit of recap. Then we also spoke about the major components of an information system. This is also important for you guys to understand. The database, information, process, and the data. We went through this in detail, and I hope by now you understand what a database is, that it is the heart of the information system, and it is used to collect and organize all the data that is entered into the system in the tables. We also said, however, that although the user interacts with the database, the user does not see the database. They only see the user interface that they interact with. That is the importance of the database. And we also spoke about data and information, data that is collected internally or externally from suppliers and customers. And we also said that this data is then later translated into meaningful information that can be analyzed in management reporting to see trends on what is happening with the data. I gave an example about sales and stock, that the data that is collected from the point of sale system is used to generate reports on to see which products are selling the most, or how much sales did we make in a week, reports like that, and also to make managerial decisions on whether or not to discontinue a certain product, and to forecast inventory requirements. So those are some of the things that we discussed there in terms of data and information. Does anyone have a question related to that? No questions? Okay. Then I wanted to show you an example process. We spoke about an example order fulfillment process, so I thought it might be beneficial to show it to you today. If it's too small, you can please zoom in on your side, but basically this is an online order fulfillment process, just a generic one that is used in most online e-commerce platforms. So usually this is the process that is followed. So let's say you are a customer, you want to order something from a platform like Amazon or Takealot or any other online shopping website. So first you need to sign into the website if you are already a registered customer, or if you are not a registered customer, you will need to register first before you can buy items. But these days I see that they allow users to skip this step, and you can go and add things in the cart only when you want to check out. Then they will ask you to register. So that is also another option. But this is the traditional way of doing it. So a customer will sign in, select the items that they want to buy, add them to a cart, and then proceed to the checkout step. So this is also a model that is being used in the self-service terminals that we see in the fast food restaurants these days, like at KFC or McDonald's. But their interface is much more easier because you don't have to even sign in. You just go and choose items from the menu and you add to the cart, then you proceed to the checkout step. So, and then the typical step that follows is that you must make payment. So in online shopping, on the checkout step, they will probably ask you to enter delivery information, and then you will make payment regardless of what type of payment you are using, whether you are paying by credit card or smart EFT. There's so many payment options, SnapScan or whatever. But what you need to know is that behind that make payment step, there is a lot of system integration behind it to make sure that when you click submit payment, the necessary checks are done with your bank, and then verification is done via your banking app or one-time PIN to make sure that you are the correct account holder for that. I see Wikanya is saying, I can't hear you. Okay. Other people, can you hear me?
Yes, we can hear you.
Okay, so Wikanya, I don't know why you can't hear me. Others are saying they can hear. Maybe try to leave the meeting and join again. Okay. While she's sorting that out, we will continue. So I was talking about integration that is involved in a management information system. Remember, we spoke about the interfaces, and then we said the management information system can be integrated to other systems to get data. I think we gave an example of an HR system, that an HR system is probably a separate system, but in a management system, MIS that is used in retail space, they may need to integrate to that HR system to get some details of employees, like the cashier's employee number and their name. That is usually displayed when you check out, and the cashiers, if you have noticed on your receipt, there is usually the name of the person that served you. So that type of information will be coming from an HR system. So that is an example of integration. So in this example of the online shopping process, that is also what happens. When you click make payment, there is a lot of integrations that happen in real time to make sure that your payment goes through and you actually receive a message back to say that your payment was successful, and then your order can be completed. But after that step, there are a lot of other processes that happen in the background which the customer does not see. For example, the sales department will receive your order after you have made payment and order is confirmed. Then the system checks availability of the stock items that you ordered. If it is available, then generate a delivery invoice. If it is not available, then they must first order the item to a supplier. So these days, all these steps are automated. So usually, if you want to order an item, you will see, let's say, take a lot, for example, it will tell you stock is available. You can expect delivery tomorrow. Some items, it will say delivery in 7 to 14 working days. So those type of items are items where the stock is not kept by Take a Lot, but they need to get it from the supplier. So when a customer orders, then an order goes to the supplier through the automated system. So that is what it means. And then there is also a finance process that happens in the background where the invoice is settled against the payment that the customer made. And then there is also the distribution step where someone or a robot must go pick your order in the warehouse, pack it nicely in a box, and send it out for delivery. So that is generally how the order fulfillment process works. But I know these days there is a lot of automation. So most of these processes automated. So I think it is just a nice example so that you can understand where computers and management information systems fit in the day-to-day running of a business. So the order fulfillment process is just one example, but there are many processes that you can also look at. So maybe you guys have other examples of processes that you can think of that use information systems. Last week, we also spoke about the banking example, that behind the ATM interface, there is a process designed step by step to tell the system how it must react when a user pushes which button on the interface. So that is how computer systems are useful in our day-to-day lives. So most of the time when we interact with computers, we don't even think about the process behind it. We just think that is something that we use in our day-to-day life, but this is what you are studying. So that is why I try to give you guys simple examples that you can relate to. I hope that helps. Okay, so then the topic for today, if you have gone through your textbook, you will see that they start with defining a computer system. So yes, we all know what a computer is, but you need to understand what it means. So it is a machine that accepts data as input, processes that data without human intervention using stored instructions, and it outputs information. So you can think of it as there is input part, which is what the user enters, whatever instructions, whether you enter that instruction through a keyboard, a mouse, a touch screen, whatever that instruction is, it's an input. Then the computer processes that input based on the stored instructions. The stored instructions is the computer program, whatever program it is, that then processes that input and outputs the information. So let's say you are going to the ATM. You insert your card. That is an input. Then the ATM reads your card information, display instruction on screen. Then you you must choose what you want to do at the ATM, whether you want to do a deposit, a withdrawal, check balance, whatever. Then let's say you select check balance on the screen. When you click on that button, it is an input. Then the computer must process that input based on the programmed instructions. So in that case, then the computer will go through the program for balance check, for example, and then it will go through the different steps and validations. Go to the account, check the balance and display it on screen, for example, or print it if the user selected that they want to print a receipt. So that is an example of the input process output that happens with a computer. So an ATM is a simple example that we can all relate to. Can you guys think of another example in our daily lives where we have this process of computer input, processing, and output? Anyone can think of something? So the program refers to step-by-step directions for performing a specific task. So you can think of the program as code that is being executed when the user clicks a button. So if the user selects they want to withdraw cash and they select an amount, the program behind that process that is then executed, the computer processes that input without human intervention and goes through step by step the directions on what it needs to do in order to for the user to withdraw cash until the steps are done and the money is dispensed from the ATM. So you can just think of a program as the code behind. It doesn't matter what programming language that it was written in, but it says here the program is written in a language that the computer can understand. So there are many programming languages out there, but all of them are basically just step-by-step directions for the computer to process the data without human intervention. And with any program, there is the concept of garbage in, garbage out. Basically means that whatever you program the computer to do, that is what the results that you're going to get. If your code is not up to standard, you cannot expect the computer to give you excellent results. So that is why it's important for us to write programs that are logical. That is what you will learn in your programming modules. I know some of you are probably doing visual programming and maybe C++ for those who are enrolled for computer science. So there you learn about logical program design so that you can be able to write code that is logical. Okay. Are there any questions here? I don't want to be the only one speaking. Okay. Then, still on the topic of the computer system. Oh, okay. F. Mycella says, I don't understand. Garbage in, garbage out. So think of it as, have you worked with Excel? You've probably worked with Excel before. So let's say you have an Excel sheet with some numbers for, I don't know, whatever you are trying to calculate. And then Excel uses formulas. So you go and enter a formula. But if your formula is not correct, you cannot expect to get the correct results. That is what it means, garbage in, garbage out. So if your formula is garbage, the results that you will get out will also be garbage. So let's say in your formula, you are adding a range of fields. Let me see if I can find an example. A range of fields, and then one of those amounts is incorrect. Maybe you are trying to calculate the average of the class average for the INF1505 group of students, as an example. And then one of the amounts is incorrect that you, in your input, let's say you made a mistake and entered 950 instead of 95. So that is garbage in. So the result that you will get, it is also going to be garbage out. So what you put in determines the result that you get out from the computer program. Basically, that is what it means. I hope that clarifies it for you. Okay, Nozipo is asking, what chapter are we discussing? Okay, so Nozipo, maybe you joined a bit late. So we're talking about computers and their business applications. So this is probably chapter 2 in the MIS book. It's chapter 2 in your MIS book. So it talks about defining a computer and the components of a computer system. So now we were talking about defining a computer. That is where we are now, talking about the input processes and the output. Okay. Thank you, Nozipo. So that is what I was explaining there. Then the computer has got many different components. So these are different from the components of a MIS. So that's why it's important to distinguish between a management information system and a computer system. So a computer system is like the PC that we are using. Like now I'm using my laptop. The computer system, it has got hardware components and software components, and also the central processing unit. So the hardware components is the things that are physical devices, like the keyboard, monitors, processing units, the mouse. All of these things are hardware components. Then you have software, which is programs that are written in computer languages. Can you guys give me an example of software?
An antivirus.
Yes, antivirus software.
Microsoft Office.
Yes, Microsoft Office is also software. So basically, software is the thing that enables users to be able to use the computer. So without the software, we can't use the computer to do anything. So if you think about it, let's say you're using Microsoft Office, you use that software to do many different things. Maybe you need to type out your assignment in Microsoft Word, or do a PowerPoint presentation. All of that is software. Even Microsoft Teams that we are using now for the online classes, it is a software. So software enables us to be able to use computer programs. That is the way to explain it. Yes, Google, it is also software, and then Chrome is a web browsing software. Like for Microsoft, we have Microsoft Edge. It's a web browsing software. So yeah, well done. You are on the right track. So you understand what software is and what hardware is. Then we have the CPU, which is the central processing unit. It is the brain of the computer. So everything that we enter, we give the computer as input, it is processed through the CPU. Then we have the arithmetic logic unit, the control unit, and a single or a multiprocessor. I just want to see what they said about that in your book. Oh, they also talk about the motherboard. So these are the basic building blocks. So the arithmetic logic unit performs arithmetic operations, like it says. Arithmetic is things like addition, subtraction, multiplication, all of those things, and things like relational operators that you would use in programming languages. For example, the and, or, the greater than, less than, equal to, all of those things are processed by the arithmetic logic unit. So you can go read the detail in your textbook. There is quite a lot of detail. Then, okay, this is the diagram from your book showing us that we have input devices, the devices that users use to give computers instructions, whether it is keyboard, mouse, a touch screen. There are other types of input devices. That are not common, like voice instruction. We can use a speaker as an input device. So on your phone, if you use Google Assistant or Siri or one of those, you are using your voice to give instruction. So that is a form of input. So there are different types of input devices, but the ones that are listed in your textbook are the ones that you need to know for this module. Then you need to know what happens when the computer processes the input and then gives the output. So output devices are things like monitors when the computer gives the results on screen, or a printer if you are printing the output, or a speaker if the output is in sound format or video. So all of those are different types of output devices. Do you guys have other examples? Output devices?
A printer.
Yes, definitely a printer is an output device. Anyone else? I don't know what it is called, but you know, if you have seen those games where you can just use hand gestures to play the game, that is also a form of input. I forgot the name, the term that is used for that, but that is a form of input. Yes, Simiso says a projector. Yes, it is also an output device. I forgot about that. Projector is an output device. Thank you for that example. Okay, but we get it.
What about those machines at the malls, you know, the parking lots where you have to wave your hand and then it gives you a parking ticket?
Oh, yes, that. I don't know what is the term for that. Does anyone know what is the term for that technology? I must Google it. I don't know what it's called.
Maybe sensor machine.
It could be a sensor. It could be. Okay. Yeah, if someone finds out what it's called, please let us know in the chat. Piwa Nkosi, I see your hand is up. You can go ahead. Is it Piwa Nkosi or Dino? Which name do you prefer? Piwa? You are unmuted, but I can't hear you. You can just put your comment in the chat. I can't hear you. Please unmute, Piwa, so that we can hear your point or your example. You are muted again. Oh, okay. A radar screen, is that what it's called? Okay. It's fine, not a problem. Thank you, Piwa. So it is a radar screen. Okay. That is interesting. I never thought of that. So it shows you, Nozipo, that we are interacting with these technologies every day, but we don't really pay attention. You just know that you go wave your hand at the machine, then your parking ticket comes out. But yeah, thank you. So it's a radar screen. Thank you for that. Okay, then some more components of a computer system. There is what they call a bus, which is the link between devices connected to a computer. So the bus connects your devices. So if you have your keyboard, your mouse, headphones, whatever, they are linked through the bus. Oh, okay. So you're saying a radar screen as an output device. Okay, so let's say, for example, what they use in the X-ray room Is that what you're referring to? That they can see the X-ray on screen. Okay, maybe that is what you're referring to. Yeah, it will be interesting if you can be able to speak to us, then we can understand. Guys, if you understand what Piwa is referring to, please also assist what the radar screen is. Okay. So, you guys can search for that in the meantime. What is a radar screen and how it is used as an output device while we continue. Okay, we will come back to that example. Thank you, Piwa. So, air traffic signals. Okay, yes. So then it makes sense as an output device. Thank you for that clarification. Okay, so the radar screen is an output device. So we still need to go and find out for homework what is the term used for that technology where you can wave your hand for the parking machine. Is it a motion sensor or what is it called? Okay, that is homework for all of us. Okay, then we have computer performance factors, the processor, which is the CPU we spoke about, the bus, which connects all the peripheral devices, and then we have the operating system. We haven't really spoken about the operating system. So it's hard to define the operating system. So on each computer, you will have an operating system. Whether you are using Windows, I'm using Windows. Just like with smartphones, we have an operating systems, Android or iOS, depending on the type of device that you have. So the operating system makes it possible for the user to interact with the computer. It is different from the software. Therefore, the software does a specific thing, but the operating system makes it possible for the user to use the computer system. I'm just trying to see if there's a proper definition here in your book for what an operating system is. Do you guys have the book with you? You can please also check for me what it says. We do a quick find. Okay. If you go to section 2.7, it talks about what is software. They also talk about the operating system, Windows as the common operating system for most PCs. And they're saying this type of software works in the background to take care of housekeeping tasks, such as deleting files that are no longer needed, okay, and filing your documents. So let's say on your computer you have different folders. You can create a filing system for yourself on the C drive to be able to store your files according to different categories. So there you are working with the operating system. So according to the definition, they distinguish between system software, which is the operating system, and application software, which will be like your Microsoft Word, Microsoft Excel, the Office 365 is the application software. And then the system software is the operating system. I hope that makes sense. So the operating system is a set of programs for controlling, managing computer hardware and software. It provides the interface between a computer and the user and increases computer efficiency by helping users share computer resources and performing repetitive tasks. So that is what an operating system does. So without the operating system, a user you will not be able to use the computer. So that is what it does. Before you can even use the application software on the computer, the operating system, which is a set of programs, must be in place. I hope that makes sense. Okay. So, Pure, I don't know if that is a new hand or is the old hand, but if you have another question, please just put it there in the chat. That was the operating system. You can go and read the detail there in section 2.7. Then we have other components like the disk drive, the CPU, and the main circuit board or the motherboard. So this is what they look like. The first picture there on the left-hand side is the disk drive, which is computer storage. Then you have the motherboard, circuit board, and you have the case. So this is the components that they want you to know. But you can go and read through the section about the operating system and application software so that you can understand the difference between the two. And there are different types of software. We only spoke about the Microsoft software example, but there are many different softwares out there, like graphic design softwares. Maybe you have used Photoshop as an example. It is a software. Then there are many software used for financial planning, project management software, like Smartsheet. They also give an example of QuickBooks. It's also an example software, computer aided design, CAD software. So all of those are examples. HR softwares, yes, thank you, Nozipo. So there are many different types of softwares that are out there, depending on what you want to use it for. Okay, then there is also the history of computer hardware and software. You just need to know the history. They might ask you a question or two about the history in your exam. You just need to be able to know what is first generation, second, third, and so forth. So currently we are in the 5th generation of computer hardware. So this means parallel processing technologies, chips, gallium arsenide. I don't know what is that technology, but it is in the current generation, and optical technologies. Whereas in the first generation, dating from 1946 to 1956, they use vacuum tube technologies. So you must just be able to know the different generations. For those who are doing INF1520, I know that the first lesson in the study guide talks about the history of computers. So if you are doing INF1520, then that will be very useful to go and read up on that section about the history of computers. They ask questions related to that. History of computers for INF1520. And I think the study guide then explains it better. Then you can understand the different how computers have evolved over the years, starting from the mainframe computers up to what we have today, how technology has evolved, and how even in size, the mainframe used to be like a computer that fills the whole room, but now we have computers that are so small and portable. So that is just how computers have evolved. So you can go and read up on the history of computers just for your own understanding. And then we also have the history of computer languages. This is programming languages. So you need to understand first generation, second, up to the 5th generation languages, and just know the differences. So the languages that are used these days, programming languages. I'm speaking about programming languages. So high-level languages like C++ and Java, those are third-generation languages. And then you have fourth generation, which is like SQL, Python. Those type of languages use English like instructions. So it is not like code that no one will understand. So if you are just a normal person who can read English, you can easily read a program written in Python and be able to tell what the program is doing. So those are fourth generation languages. Do you guys have other examples? Do you know of any other example of programming languages, third, fourth, fifth generation? Fifth generation is natural processing language. So it's like normal programming that is done in normal English language instructions without any complicated keywords, if I can call it that. Do you guys have other examples of programming languages? First generation, they said it's machine language. So if I remember correctly, first generation was just machine language using binary numbers, the zeros and ones. Do you guys have any other examples, programming languages?
Can I just ask one question?
Mm-hmm.
Are we supposed to know the examples, for example, of these languages that Java is part of the assembly language, or Python is part of the fourth generation? Are we supposed to know that? Like different examples of all these languages?
I think you need to know not how to write it, but just to know it is there in your textbook, section 2.8. They talk about the different languages and give example of the third generation languages, fourth generation. So you just need to know the examples, not how to write code in those languages. No, just the examples.
Okay.
I will maybe look for past papers so that you can see how they ask the questions. Then it will help even when you're preparing for exam, because this module is not a standalone module. So information system as a whole, you need to have this basic understanding. But I don't want to go into too much detail. I just wanted you guys to think about the examples. If you are able to tell that fifth generation means it is natural language processing. It is visual programming. So you just need to understand the basics of what it is. Okay, thank you for the thumbs up. Are there any other questions here or comments? Okay. No questions. Then we also need to talk about the power of computers. So the factors that make computers exceed human capacities. The first one is speed. We all know that computers can do things fast, very fast compared to human beings. So that's why we need to talk about speed. Then there is also the factor of accuracy and the factor of storage and retrieval. So remember when we defined the information system, we said its function is to collect data. So collecting data has to do with the input that we spoke about now from input devices from users. Then it organizes and it stores the data, and then it analyzes. So those 4 functions you need to understand, and how all these components of a computer that we are learning about relates to each of those functions. So input devices are linked to the data collection function of a management information system. And then devices like the hard disk and memory related to storing of the data. And then we have the CPU, which is responsible for the processing. So when you read these things, you must be able to link the concepts together so that you can be able to explain it in your own words and be able to answer questions. So these are just some of the factors. So the first one is speed. Computer speed is measured as the number of instructions performed per fraction of a second. Then we have the speed in millisecond, in microsecond, in nanosecond, and in picosecond. I don't even know how to read that fraction. So if someone knows how to read that fraction for the picosecond, please help. So this is how computer speed is measured as a fraction of a second. So the millisecond, we can understand how fast that is when we say the computer speed is 1. Sure, how do we read this fraction? 1/1000 of a second. Is that how you read it? That is what a millisecond is. So what is a picosecond? So you can imagine how fast that speed is. So probably when you go and buy your device, you always look at the processing speed before you make a choice on the type of device you're going to buy. So that is how the speed of computers is measured. And then, does anyone know how to read this? Picosecond. How do we read this fraction? I don't know how to read that fraction. But I know it is very fast. So, yes, as long as you know how speed is measured, there are 4 different fractions of speed. I think that is good enough. Then we also have the factor of accuracy that makes computers exceed human capacity. So computers do not make mistakes. They process instructions based on the input that we give them. So that is why computers are accurate. And then the degree of accuracy is critical in many computer applications. Example, space mission calculations. So that is very critical. Yes, Oscar. So this accuracy is based on garbage in, garbage out. You are right. So thank you for noticing that you are showing that you can link the concepts together. Well done, Oscar. So based on what you put in, the computer will process those instructions and then give you the output. So accuracy is very important. For example, in space mission calculations, because if you make a mistake, it can cost people's lives, and it can cost millions and millions of dollars. So that's why it's important to be accurate. I was watching a documentary the other day. Not sure if I can speak about it, but it was about this sub that was built by a scientist to go down to the Titanic site. I think it is 4,000 miles below sea level. So part of that that led to the disaster is because accuracy was not taken seriously. So they did multiple tests. However, even though they saw that their device is failing by a nominal margin, they chose to just assume that it will work. This is why accuracy is so important. So accuracy is critical in many applications. So imagine if a banking system is not accurate, how people can lose money, or you just see money disappearing, things like that. We have heard of so many people scammed and their money disappearing from their accounts. So that is also a factor of accuracy. You would not be able to pick that up if the system was not accurate. Then we also have the issue of security. We will talk about that in a later chapter where we talk about security of information systems. But yeah, accuracy is very important. Then the third factor is storage and retrieval. So storage has to do, when you hear storage, just think of the disk. So the hard drive is responsible for storage, saving data in computer memory. Retrieval is accessing the data from memory. So when you go and query something, it is retrieving the data. When you have saved a file and you want to go and open it, that is retrieving. So this is an important function of computers, storage and retrieval. Data is stored in bits and bytes. So 8 bits is equal to 1 byte. So 1 byte is made up of 8 bits. That you need to know. And then the binary system is made up of 0 and 1s. That is the first generation computer language that we spoke about earlier. So the first generation machine language, it is the binary system. Then we have the American Standard Code for information interchange. So this code represents data transfer between computers and networks. You just need to know about that. That is all that you need to know. Then you need to know the overview of object-oriented programming, but I didn't go into that detail. It is there in your textbook. You can just go read the summary of object-oriented programming and the advantages and disadvantages. For those who are also doing programming languages, I think you will know this already. So object-oriented programming is these programming languages that are organized around objects that represent real world entities, as opposed to the olden day languages. So earlier I gave an example about Python and C++. Those are object-oriented languages. So you can go read about that to understand what that is about. Then, are there any questions or comments? Okay, no questions or comments. That means you guys understand. Okay, then input devices. Earlier we referred to input devices and we gave some example, but the function of input devices is to send data and information to a computer. Examples of input devices: the keyboard, mouse, touchscreen, light pen, a trackball, data tablet, a barcode reader. Yes, this one is very important. I forgot about this input device. When we spoke about the point of sale system, we did mention that when the cashier scans your groceries at the supermarkets, they are actually using a barcode reader. So that barcode holds the information of the product that you're buying. So a barcode reader is another input device. Optical character reader, magnetic ink character reader, optical mark recognition system. So those are all examples of input devices. Output devices for mainframes and personal computers. Soft copy. Output devices, it's monitor, your computer monitors your screen. And we have cathode ray tube. I don't know what that is. Liquid crystal display. This is LCD, like what we have with the LCD TVs. That is a type of output device. Then hard copy output devices, we have printer, inkjet or laser, and then we also have voice as an output device. Do you guys have any other examples that you can add here? I know Piwa spoke about the radar screen. Any other examples of input-output devices? So let's take, for example, an access control system where you can go scan your finger to gain access to a building, or you scan your eye, for example. What is that called? Because that is input. Do you guys know? Is it optical character reader? But I know that is called a biometric system. So that is also another example. You guys agree? Okay, thank you, Tavang. Tavang says yes. Okay, then we have memory devices. So memory devices are used for storage. It stores data and information, and this is volatile. So we have secondary memory devices that are non-volatile, holds data when the computer is off or during the course of a program's operation. And it also serves as archival storage. So the examples there, we have the CD-ROM. I don't think people still use that. Yes, Tawang says that is used a lot in big organizations for security plus human resources. Yes, thank you, Tawang, that is correct. So other example of memory devices, your USB drive, memory card, all of those memory devices. Okay, I think we can go to the practice questions. Do you guys have anything else to add here for memory devices?
Where does cloud storage, does it fall under main memory or secondary memory?
It would be main memory. So if you think of cloud storage or your computer hard drive, that is main memory. Then secondary is the type of memory that you can remove, like the USB device. So thank you for that question. So cloud will be main memory. So right now we're using OneDrive. It is cloud storage. So you can be able to access it from anywhere. You don't need to carry an external hard drive or a USB to access your data. You can access it from anywhere. Thank you for that, Wikano. Okay, some practice questions. So this is multiple choice type of questions, typical of how they will ask questions in the exam. So I'll just read the question, then you look at the options and put your answers here in the chat. So the first question is, is the size of a character? Is it option 1, a nibble, a bit? Option 3, a byte. 4, a word. Okay, Oscar says it's a byte. A byte is the size of a character. Others, what do you say? Itumeleng says bit. Wikana also says byte. Okay, so we are saying a byte is the size of a character. Nozipo is between bit and byte. Okay, so if you were writing an exam, you can't be between two answers. You will have to choose one, even if it is a guess. So Tabang says bit. Tembisa says byte. Okay, let's verify this from the book. What are they saying about a character, size of a character? Okay. I'm just doing a quick search in the MIS book. So, okay, you are right. A byte is the size of a character. So that is under section 2.3C, storage and retrieval. So the correct answer there is byte. A byte is the size of a character. Well done. To those who got it right. Okay, next one. CD-ROMs and DVDs are examples of magnetic tapes, RAM, optical discs, main memory. CD-ROMs are examples of Nosipho says optical discs. Itumeleng also says number 3, optical disc. Okay, optical disc. So number 3 is the answer. We all agree on that. Great. Okay, so CD-ROMs and DVDs are examples of optical discs. Good. The next one. The control programs of Oscar says it's with the majority. Hi, okay. Third question. The control programs managing computer hardware and software perform the function to control and prioritize tasks performed by the CPU. Is it 1, application management, 2, resource allocation, 3, data management, or 4, job management? Itumeleng says 2, resource allocation. When they say control programs, it sounds to me like they're talking about the operating system here. So I think they're asking what is the function of the operating system in managing computer hardware and software. Okay, application management. Number 3, data management, application management, or all of the above. Resource allocation is one of the functions. Yeah, so it sounds like it's all of the above because data management, resource allocation, job management. They should have added another option there to say all of the above. But yeah. I think all the answers are correct there. So I don't know how they were going to mark this question. Whether you select job management or application management, resource, those answers are correct. So this is that section 2.7 that talks about operating system software. Okay. Yeah. So the answer there is no one specific answer. There should be an option 5 to say all of the above. You can, if you're not sure, that is how I feel after reading this section 2.7. So you can go and verify. Okay, the next one. An operating system is, number 1, a set of programs for controlling and managing computer hardware and software. Option 2, an operating system is a computer and all the software for managing network resources and offering services for a network. Or number 3 is a collection of disk drives used for fault tolerance, typically in large network systems. Or number 4, the main circuit board containing connectors. Okay, I see majority of you are saying option 1. So we are saying an operating system is a set of programs for controlling and managing computer hardware and software. Yeah, that is correct. So it is option 1. So that one is clear and straightforward. Okay, something interesting. Something interesting that I saw in your book, it is the case study about the brain behind Apple devices. And then they talk about the major features and components of iOS. And then they ask, how is iOS unique from Android? Has anyone used both an Apple device and an Android device, and just to see how the two differ? I'm interested to know. So one of the major feature that they mention is Siri, which provides a voice interface for ordinary tasks, and then Maps for visual, spoken, turnaround navigation, real time. We also have Google Maps for this. Then sharing, photo sharing, Passbook, which allows you to add passes to Passbook through apps, email, stores, etc. Then FaceTime. And Safari for web browsing. So I'm interested to know if anyone has used both. Okay, Tulani says Android is more open, which can increase the risk of malware. That is true. Security for iOS is the best. Okay. Wow, thank you, Tulani, for that. It's interesting that here, okay, they do mention accessibility. Accessibility, easier to use Apple devices for people with vision, hearing, learning, mobility disabilities, but they don't say anything about security. Okay, it is something that I just found interesting. If we can compare iOS and Android. Yeah, but thank you so much to Lani for that. It's interesting stuff. Okay, then I think we have come to the end of our session today. So I am available to help you guys with any of your first year information systems modules. So not only INF1505. So if you have any questions or need some guidance on how to navigate some of your modules, you can send me an email. That is my email address there. Then I can book a one-on-one consultation with you on Teams. I know some of you are probably doing computer science modules as well. So if you need assistance, you can reach out to me. It is absolutely free of charge because you are a registered student. So you don't have to go and pay someone to help you with an assignment or anything like that. So that is why we are here. We are here to support you guys to make sure that you pass your modules and that you are able to navigate your studies, because we know that distance learning and online distance learning can be quite difficult, especially for first year students. So that is why we are here to assist you guys. So yes, please feel free to reach out to me on email or here on the Teams chat. Then I will be able to assist where I can. And then one last thing before we go, the evaluation form that we need to complete. I'll just put the link here in the chat. If you can please just click on the link and complete the evaluation form. On the form, you will see that it asks you for the name of your facilitator. Then you choose, my name is Tondani Moketsi, and then you answer the rest of the questions as you see fit. It is just for us to see how we can improve the sessions. So yes, thank you guys. That is it for today. We will meet again next week, Thursday, 17:30, and then we will continue with the next topic. Thank you so much. Have a good evening further. Okay, bye everyone.
Bye.
Bye.